Dissolved oxygen, or DO, is the amount of oxygen available to aquatic organisms in the water. Oxygen enters a stream through aquatic plants and algae and from the atmosphere. For every million molecules of stream water, there's only about 10 molecules of dissolved oxygen. This can be stated as 10 parts per million of dissolved oxygen. This is also equivalent to 10 milligrams per liter of DO. Missouri's water quality criteria for streams supporting aquatic life is at least 5 milligrams per liter. Once oxygen gets below this limit, there will be a decrease in aquatic life, including fish kills. Low oxygen levels can occur during summer months in non-moving bodies of water, and as a result of excess organic material or as a result of algal blooms. Dissolved oxygen levels are the lowest just before sunrise as plants and algae respire overnight, which uses oxygen rather than releasing it. To get a more accurate understanding for how oxygen is available to aquatic life, we also measured DO saturation. This factors in water temperature. For quick-moving streams, such as Ozark streams, a DO saturation above 80% is indicative of a healthy stream. For slow or non-moving streams, like prairie or lowland streams, a healthy stream can have a DO saturation as low as 60%. Dissolved oxygen is measured in milligrams per liter using a Hach dissolved oxygen kit. This kit uses a Winkler's titration method to determine how much oxygen is available in the sample. It's recommended to take the sample from the bottom of a riffle, or at least from moving water if your site does not have riffles. When you collect your sample, you might disturb the stream bottom. Take care not to collect floating sediment in your sample bottle. It's recommended to place the stopper in the sample bottle while the bottle is still underwater. When you pull your bottle up, there will be a small amount of water pulled around the stopper. This small amount of water will reduce your chance of getting an air bubble during the next step of adding DO1 and DO2 reagents and returning the stopper. An air bubble is also possible after adding DO3, which fixes the chemical reaction. To reduce the chance of an air bubble at this step, you can hold the stopper vertically just above the mouth of the sample bottle, then drop the stopper into place. The last step of measuring DO is a titration with sodium thiosulfate. The most common errors we see with DO occur at this step. When you are dropping the sodium thiosulfate, keep the dropper vertical and slightly inside the bottle. You want the drops to land directly in the sample, not run down the side of the bottle. Make sure you are giving full, confident squeezes of the dropper. Then fully release the dropper between drops. It's possible to get smaller drops when the monitor is apprehensive with the dropper and if the dropper is held improperly. This results in a measurement that is too high. Waste from this kit is fully reacted and non-hazardous. This can be discarded on the ground away from the stream or containerized to be poured down the drain at a later time.